Hey everybody, this is Larry. This is day 13th of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 207 course schedule. Yeah, no drone video today. I did install my a new air conditioner, so hopefully I'll actually get some rest and sleep maybe. But not that I don't know. Just in case you were very curious about the inner lives of Larry being back in New York City. Anyway, I don't know. I don't know why I had to say it like that. But anyway, today's problem is 207 course schedule. So this one is canonically the example that I like to use anyway, and I think is very commonly used for topological sort. Yesterday we did a queue-based solution. This time I'm going to do a recursion-based solution, and I think it's very easy to kind of fall into a bit of a trap where you're just like, oh, let's memorize these patterns, right? And the way that I don't do, and the reason. Well, I mean, the reasons I think, like, it's obvious, right? Like, the whole, learning shtick. I don't think I have to, hopefully don't have to pound the virtues of learning thoroughly. But I think one side benefit about this is that you are able to program these in any languages once you are able to, different languages have different patterns, and maybe you might be a little bit suboptimal in some things, like maybe you use, I don't know, arrays and vectors in weird languages, and they have like weird performance issues, but you can still get it done, right? So that's kind of the thing of problem solving and having the ideas. And I sometimes get this question, not a lot anymore because I guess my YouTube is all in Python, so people just take it for Python. But when I first started in competitive programming, when I started, I was I don't know, 13, 14, 12, something like this, in high school. I did computer graphics and not at that time I didn't do competitive programming, but I did computer graphics. Just kind of self-learned myself linear algebra and all these other things that I needed for computer graphics, like 3D and how everything transform and all this stuff, right? I have a point, I swear. I mean, this is also a pretty okay problem, so we'll hopefully you're here for Larry and not just the code per se. Though we will go over it, so don't worry about that, because I like teaching topological sort in both ways. But I think my point is that I started in C. I technically I started in Perl, but I did C for computer graphics. I even wrote some C Perl interfaces, which were kind of interesting because there are a lot of weird memory corruption and how they interface. At least back then, this was a long time ago. I mean, I think as soon as I said Perl, you realize it's a long time ago. But yeah, so when I first started competitive programming, and it wasn't known by that term yet, it was just like algorithms or something like this, or top coding if you want to call it that. I actually did it in C. Not even C++, and C++, keeping in mind that back then, at least in competitive, did not have STD. I mean, maybe it had. I think it kind of had STD, but people didn't use it because it wasn't very either performant or maybe it wasn't allowed by contest or something like this. But people just didn't use it back then. And maybe my memory is just really bad. So let me know if that's not really true. So I did a lot of stuff in C, and I did a lot of stuff in C++ once that became more standard, because back then a lot of the top people actually did things in Pascal, if you believe it. I believe it's Pascal. It's either that or another P language. It's not Python though. But anyway, I believe it's Pascal. But yeah, and in Top Coder actually, I did everything in Java and C++. And C Sharp rather. So yeah, and if you watch the beginning of my YouTube journey, if you will, or Twitch journey, or whatever you want to call it, the journey, I did still do things in random languages, and I was starting to learn Python. I mean, I knew Python, but not necessarily to the degree that I do today. Like the basics, I got, but I'm probably better now, right? I mean, it's hard to be worse if you're practicing, but I guess some people manage to do it, but I did not. fortunately. So so that's a long around saying that I took, like, the algorithms I never lost, and if I have to go back and write stuff in Java or C Sharp, I probably lost a step or two, but I can still reconstruct everything, right? So definitely, when you think about patterns, at least think about how solving patterns, right? For this one, there's a very good one. I didn't really go over it yesterday because yesterday's problem, we were going over how that was effectively topological sort, though it's a little bit awkward. But this one is topological sort and a way easier way to kind of explain it, right? And because in this particular problem, you could do it in a very English way. By English, I mean just like me verbally explaining to you, right? You can take any class and be like, okay, Larry, I want to take this class. Well, in order for me to take this class, I have to take all the prerequisites, right? So then let's say I have to take, I don't know, physics 301. I have to take physics 201 and 202 and all this other stuff, right? And then recursively you go, okay, so now I have to take physics 202. Well, that means I have to take this other course first, and like maybe calculus or something like this, right? Modern physics. And, so the idea is that you can kind of, for each thing, you can map a unit of thought almost, right? Of, okay, I need to take this class. What do I need to do before taking this class? And then you just keep on recursively asking it. And that's how you kind of, like if I have to take A, or if I want to take A, I have to take B and C. Well, now I want to take B. What are my prerequisites and stuff like this? So that's basically the idea behind topological sort. And once you kind of think about it that way, it becomes really easy to implement in any language, really, or any reasonable language where you don't want to do recursion limits, I guess. But yeah. So okay, so yeah. So n is the number of courses. So I didn't actually read the problem. So maybe that would be very funny if I was just like explaining the wrong problem the entire time. So, okay. Prerequisite is an edge basically from A sub I to B sub I. You have to take B sub I first if you want to take A sub I. Okay. So, okay, yeah. So we could just construct an adjacency list or prereq list maybe. Maybe that's a little bit better. I don't know if it is. And it would be better if I know how to spell now. But yeah, and then for UV, or I guess AB in their lingo, in prerequisites, can't spell now. Prereq. So we want to say that in order to take A, we have to take B first, right? That matches what they say. So this is what we're gonna do, and that's all there is, right? Oh, and here actually I thought I was trying to get I really thought that we were trying to get like the list of the order of the list to take, but apparently it's just true false whether you can do it. So yeah. So then I mean, okay, I kind of lied then. It's not necessary topological sort. You can also do something with cycle finding. Okay, I don't know. I got fooled a little bit by the name because I didn't actually read the problem. But topological sorts can still do it. It just doesn't terminate, right? So anyway, so yeah, so let's just say we take this class X, right? So then now for Y in prereq list of X, we want to take Y, right? So now yeah, I mean, it just becomes a little bit of a cycle finding, and you can kind of see how do we want to do it. I mean, we can do the recolor thing, the black, white, gray thing, but I'm trying to think whether, yeah. So okay, let's just say taken is equal to force times num courses, right? Maybe we'll just do the color thing, right? Yeah, I guess so. Yeah, so then let's just say black. I always forget the colors that people use, or like the I forget whether people go from black to white or white to black. I don't know. Yeah. And then basically now, to take this class, we go, okay, taken of X is equal to gray, and then afterwards taken of X is equal to black or white after we taken it. So then if taken of Y is equal to gray, that means that there is a cycle. We are set. So yeah. So then return false. Otherwise, yeah. If not, return false, right? Maybe something like that. And then now, we can say if taken of I is equal to black, then we should take I, or if not this, then return false. Otherwise, we can return true. Yeah, I think that's pretty much it. Oh, oops, got my thing. We don't have to do this if we already taken it, which means if it's right. If taken X is equal to right, continue. Otherwise, this is equal to black, and then you do stuff. Ooh, I knew that I don't know how to spell prerequisite. What did I even write? I don't even know what I want. Yeah. The test cases are kind of weak, so I'm debating doing a further check, but I'm just gonna YOLO submit. Oh no, get an infinite loop. Drop something. What did I drop? I was a little bit lazy. Let's see. I probably have a bug in my code somewhere. It's not because this is too slow. I mean, it's too slow because I have a bug somewhere. If taken of Y. Oh, whoops. Okay, well, I guess my logic is fine. Okay, well, oh man, it's my first time failing this because I typed taken of X instead of taken of Y. This is what happens. I drop my mouse pad. Yeah, I mean, so this is kind of, you know, to take X, we have to take all the prerequisites, and we're just kind of recursively doing that. And that's really it. This is a very textbooky problem, one that I still got wrong somehow, I guess. But yeah, but the idea, like I guess I'll go back to focusing on the idea. The idea is the important part, and the idea, you know, we you know, like I clearly did not have a pattern about this. I just wrote it in a weird way, and therefore, you know. But yeah, cool. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.